Hey guys, our next lecture is we'll see how XOR works. XOR is exclusive OR operator. It's denoted by the pipe symbol in Java, and it's a bitwise logical operator, and it's a binary operator. That means that it takes two operands. So the definition of XOR is if either of the operands is 1, then only the resultant is 1, else the resultant becomes 0. What does that mean? If either of the operands, if right side operand or right side operand is 0, then only the resultant is 1, else the resultant is 0. Okay. This is our first observation. Okay. The second, we will try to generalize what is it. So I'll say that 0 XOR with n or n XOR with 0 is 0, and n XOR with n becomes 0 from here, right? 0 XOR with n or n XOR with 0 is 0, or when I do n XOR with n it becomes 0. Let's try to put some example and see how it works. Let's put n equal to 13. What is the binary representation of n equal to 13? Is 8, 4, 12, 13, right? 2 power 0, 2 power 1, 2 square, 2 cube, right? 8, 4, 12, 13. And when you do XOR with n XOR with 0, 1, 1, 0, 1, that means 0, 0, 0, 0. Let's go to truth table and find out. 1 XOR with 0, 1, 0, 0, 1, 0, 1, 0, 1, 1, 0, 1. So it's nothing but we got 13 back. So we got this one proved. Let's try to with the 0 XOR with n or n XOR with 0. So 1, 1, 0, 1. This one we are trying to prove now. Okay. Okay. 0, 1. 0, 1 is nothing but 1. 0, 0 is nothing but 0. 0, 1 is 1. 0, 1 is 1. Again we got 13 back. So this is proved. So of course we can easily understand this is also proved. So what else we can derive from this one, we will figure out now. Okay, so we applied this XOR for once on 1. Let's try to apply XOR for the same n for multiple times, n repeated by 3 times here. Let's see what's the resultant. For when n XOR with n, it becomes 0, correct? When 0 XOR with n, the resultant becomes n. So when n repeated by 3 times with XOR, it gives us the n back. Let's try to see n XOR with n repeated by 4 times. What happens? N XOR with n gives us 0. 0 XOR with n, it gives us n. N XOR with n, again it gives us 0. So if you observe closely, you can easily derive or understand that when XOR is applied on the same number for even number of times, the resultant is 0. You can test it easily. 4 or 6 or 8 or any number times, you get the resultant as a 0. On the other hand, if the XOR is applied odd number of times, it gives us the resultant as a n, the same number whatever we did. Alright, let's move to the last observation. Here, what I say is that the order in which the XOR applied doesn't matter. What does it mean? So, for example, we have two operands m and n. Okay, and consider this operation m XOR with n XOR with m XOR with m, and n XOR with n. So here what you can see is, you can say that it is 0 XOR with is n XOR with is n, again 0. This operation is allowed. But what if we need to do this operation m XOR with n. Let's run this up slowly. M XOR with n, XOR with m, XOR with n. Can we say anything about m XOR with n from here? No, right? We don't know what is m. Both are not same. We know that if m not equal to n, we cannot say anything about it, right? So it's the same thing. N XOR with m also, we cannot comment about it anything. However, let's try to observe like what can we do about it. You know, let's put some numbers and test. Let's say m equal to 8 and n equal to 5. So m XOR with n, what this gives us? 1 0 0 0 0 1 0 1. You know, right? This is 5 and this is 8. So 0 1 is 1, 0 0 is 0, 0 1 is 1, 1 0 is 1. This is m XOR with n. Now let's do one more with m. What is m? Is 8. 1 0 0 0. Correct. Let's do this operation. 1 0 is 1, 0 is 0 is 0, 1 0 is 1, 1 1 is 0. Okay. Now we can do XOR for one more time and check. N is nothing but a 5. 0 1 0 1, right? So 0 0 0 0. So the order in which the XOR operation doesn't matter for us, as long as for example in an operation, if there are even number of the same numbers, even number of m's or even number of n's, so it still gives us the same result, so wherever it occurs. Okay, so the last one more example is here. Let's see the third case. M XOR with n. Let's say XOR with n, XOR with m, and let's say that we have one more m. Here m is repeated by 3 times and n is repeated by 2 times. You can guess the result, right? So order in which the way we applied, because m, this all becomes 0 and 0 XOR with m becomes m. So these are the few observations you can try to remember. So using these techniques we can try to solve many of the problems using XOR. Thank you guys.